Before we talk about the deviation of light that is refracted through a prism, I want to remind you of what happens when light is refracted through a parallel-sided element, again, such as a piece of glass. And if the ray of light is incident at the first interface, it's refracted toward the normal, and then it's incident on the second interface, and then is refracted away from the normal. And we could extend this incident ray, and we see that the direction where the incident ray was going is displaced compared to where the actual emergent ray went. And we call that distance d, and that's the lateral displacement. And it's a little bit different when we look at a prism. Because the sides are not parallel to each other, the two refracting surfaces are not parallel, a ray of light will be incident on the first surface. Again, it'll refract toward the normal, and then when it's incident on the second surface, it will refract away from the normal. And now, if we were to extend this first incident ray, you can see there's no one distance, d, where we could say that that's the lateral displacement of the ray. Instead, the emergent ray is coming out at a different angle. And so if we were to extend the emergent ray backward, you can see where these intersect. And this angle here, we would label as delta, and that's the angle of deviation of this prism. So you look at where the incident ray was going, compare that to where the emergent ray actually went, and then the angle between the two we label the deviation of the prism. And I'll draw this a little larger now so you can see that there are two components to the deviation. If this is the incident ray at the first surface, and it is then refracted toward the normal, we could extend this incident ray, and the angle between the incident ray and the refracted ray we could say is delta 1, and that's the deviation at the first surface. And then when the incident ray is incident on the second surface, it is refracted away from the normal, and we could take the angle of this second incident ray between the second incident ray and the second emergent ray, and we could label that as delta 2. And we will find that if we were to extend this final emergent ray back, the angle between the first incident ray and the final emergent ray is going to be our total deviation, delta. And it turns out that delta 1 plus delta 2 equals the total deviation of the prism. And you can use this fact to derive another formula, which is that the total deviation is equal to theta 1, the first incident angle, plus theta 2 prime, the final refracted angle, minus gamma, which remember is our apical angle. And we'll just focus on the second equation for our example here. For this example, we'll say that this prism has an apical angle of 35 degrees and an index of refraction of 1.49, and the incident angle is 15 degrees. So if we were to draw a normal to the surface, the incident angle would be something like this. And theta 1 equals 15 degrees. And we want to know what the total deviation of this prism is. So if we have the formula, delta is equal to theta 1 plus theta 2 prime minus the apical angle gamma. So we have theta 1, but we still need to find theta 2 prime. And we can start by using Snell's law for the first interface. So we have 1 times the sine of 15 is equal to 1.49 times the sine of theta 1 prime. And we can solve for theta 1 prime to find it's 10 degrees. So that would be something like this. And now we have to remember that gamma, the apical angle, is equal to theta 1 prime plus theta 2, the second incident angle. And so 35 is equal to 10 plus theta 2. And our second incident angle, theta 2, would be equal to 25 degrees. And then we can use Snell's law once more to find the final emergent angle. And 2 is the index of the prism, 1.49 times the sine of 25. And 3, we're back in the air, so it's 1 times the sine. We're trying to find theta 2 prime. And we can find that theta 2 prime is equal to 39 degrees. And so now we have all the information we need to find the deviation. Theta 1 was 15 degrees. Theta 2 prime is 39 degrees. And gamma was 35 degrees. And you would find the total deviation for this prism is equal to 19 degrees. So if this were our final refracted angle, theta 2 prime is 39 degrees. We could compare where the first incident angle is going, compare that to where the final refracted angle went, and the angle between those two is our deviation, which is 19 degrees.